if we have an expression, so let's say n plus 2, and I put that into the absolute values, okay? And I say that that is equal to 7, all right? What can n be? Message me what you think n can be. Direct message what you think n can be. All right, somebody said 5. 5 is one of the answers. There's actually two. Someone said 5 and -5. No, -5 wouldn't work because -5 plus 2, that would give me -3. And the absolute value of -3 would be +3, not 7. So it's not 5 and -5. Someone said 5 and -9. All right, so let's look at this. If n is 5, okay, let's try that first. We have 5 plus 2, absolute value. 5 plus 2 is 7. Absolute value of 7 equals 7. Okay, so that checks out. So one of them has to be 5. Someone said -5, so let's put in -5. -5 plus 2. -5 plus 2 is -3. The absolute value of -3 is 3. But 3 does not equal 7, so that doesn't work. All right, someone said -9. N can be -9. So if we put in -9, -9 plus 2, -9 plus 2 is -7. And the absolute value of -7 is 7. So that checks out. So then my answer, n, is equal to, and again, we're going to use set notation. That's the squiggly brackets. It can be -9, comma, 5. That doesn't mean from -9 to 5. The squirrely, listen to me. The squiggly brackets simply means that it can be -9 or 5. Very good. All right. So now let's look at this question. Let's say I have the absolute value of x is equal to -3. What can x be? Send me your answers in chat. What do you think x could be? I don't have any answers coming through chat. Well, that's actually a really good thing because their x has no solution. In this particular case, x has no solution. Well, why is that? Well, remember that, um, okay, now x, the absolute value of x equal to -3. There is no solution here. And this is why. If we look at the distance that this any number has from the origin, in this case, the number 3, we see that both 3 and -3, gotcha, Crossland. We see that both 3 and -3 are 3 units from the origin. If I come down to 2, 2 is 2 units from the origin. 1 is 1 unit. And at 0, it's 0 units from the origin. There's no possible way to get anything less than 0. So we can't have an absolute value equal something that's negative. So that is why there is no solution for x in that regard. There you go, George. All right. So let's do another one here. Let's do the absolute value of x minus 2 is equal to 10. When you have it, message me. Make sure you're messaging Mr. Castro, message directly. And there are going to be its absolute value, so we're going to have two answers. We're going to have two answers. Okay, someone said 12. 12 is correct. Someone said -12 and +8. That is incorrect. -8 and +12, that is correct. 12 and negative 10 is not correct. All right. It is, in fact, 12. 12 minus 2 is 10. Absolute value is 10. And negative 8. Negative 8 minus 2 is negative 10. And the absolute value of that is equal to 10. So if we went here, 12 minus 2, that is 10. Absolute value of 10 is 10. That works. If I make it, someone said 12. I'm sorry, someone said negative 12 minus 2. Well, that's going to give me negative 14. That's not going to work. Someone said 8. Well, that's going to give me 6 in here, and that's not going to work. Someone else said negative 8. That is going to work because negative 8 minus 2 is negative 10. The absolute value of negative 10 is 10. That works. All right. So now I'm going to show you how you can actually set these up algebraically to kind of solve for that, okay? So let's look at this again. The absolute value, go ahead and take some notes here. Make sure you guys are always taking notes. I can't peer into the screen to see whether or not you guys are taking notes, but let's take notes to make sure we do well on the homework and quizzes. Now, I can set this up algebraically. And what I mean by that is if I have absolute value, there are two things that this absolute value, that what's inside the absolute value can be. The first is it can be positive 10, and the second is that it can be negative 10. Okay? So what that means is x minus 2 can either be 10 or x minus 2 can be negative 10. Okay? X minus 2 right there, that can either be 10 and give me 10, or that x minus 2 right there can be negative 10, so that when I take the absolute value, it's 10. So the x minus 2 can either be 10, or the x minus 2 can be negative 10. So here, x minus 2 is 10. Well, that's obviously 12, right? Just logically looking at that. What number do I need to have here to where I take away 2 and it becomes 10? Well, that's 12. The other thing I can do from the rules we learned last week is I can add the number 2 to both sides of this equation. Because I can add, subtract, multiply, and divide anything I want from two sides of an equation. So here I have x minus 2 plus 2. The minus 2 plus 2 goes away. Because I subtract 2, then I add 2. That gives me 0. So I'm just left with x over here. And on the right side, I have 10 plus 2. That gives me 12. Now over here, if I do the same thing, if I add 2 to both sides, negative 2 plus 2, that goes away. I'm left with x. Negative 10 plus 2 is negative 8. So that's how we can work these algebraically to find the answers. 12 and negative 8. So x is equal to, curly brackets, negative 8, comma, 12. And that one is out of ink. Negative 8, comma, positive 12. All right. Let's keep taking notes here. If I've got, let's say, x minus 5 in absolute values, but then I'm multiplying that by 2. All right, and that's going to equal 10. How do I do that? I want you guys to send me what you think the answers are. Okay, somebody said 10 and negative 5. Another person said 10. Remember, there's going to be 10. Oh, I'm sorry, 10. There's going to be two answers. All right, someone said negative 10 and 10. Someone said 0. Someone said, wait, no, I didn't mean to write that. Um, all right. So what's going on here? We've got something outside here. Interesting, interesting. All right, so let's try some of yours. Let's say somebody wrote 1 and 0. Let's go there. All right. Let's try 1. 1 minus 5 times 2. See if that's equal to 10. 1 minus 5 is negative 4. Absolute value of negative 4 is 4. That's not going to work because that's going to be 8. Okay. X minus 5 times 2 is equal to 10. What could that be? Someone else said 0 and 10. Okay, so let's try 0. 0 minus 5 times 2. Does that equal 10? 0 minus 5 is a negative 5. Absolute value of negative 5 is 5. 5 times 2 is 10. 10 is equal to 10. Good job. That same person said 0. Let's see. She said 10 and negative 5. Or no, wait, no. We did 0. Not that person. 0 and 10. All right, 0 and 10. So the other one I'm going to try is 10. 10 minus 5 times 2. Does that equal 10? 10 minus 5 is 5. Absolute value of 5 is 5. 5 times 2 is 10. That works out. So the answer is actually going to be x is equal to 0 and positive 10. 0 and positive 10. Those are the two answers. Someone said negative 8. If I put negative 8 in here, this gives me negative 13. Absolute value of negative 13 is 13 times 2 would be 26. Someone else said 10 and negative 5. If I put negative 5 in here, negative 5 minus 5 is negative 10. The absolute value of negative 10 is positive 10. 10 times 2 is 20, not equal to 10. So it can't be 10. 0 and 10. 0 and 10, good. Cannot be 1. Someone said 3. And we can't be 3 because 3 minus 5 would be negative 3. And that's going to be 3 times 2, which is 6. Can't do that. All right. So let's do another one like this. These are a little tricky. Now, what I'm going to do is I'm going to rewrite the same one. Okay, we kind of look through it by trial and error and algebraically. I'm sorry, trial and error and logically. But let's perform some of the math that we learned last time. So here, I can't set whatever's inside here. I can't set plus or minus 10 here because the only thing that's the absolute value is inside here. This 2 is going to stay as a positive 2. It can't also be a negative 2. So the only way that I can set this up by itself is if I get that 2 to the other side. So I can divide both sides of this equation by the number 2. I can divide, add, subtract, multiply, anything I want on both sides of the equation. So here, I'm going to divide by 2, and here I'm going to divide by 2. So the absolute value of x minus 5 times 2, all divided by 2, the 2 over the 2 gives me 1. 2 divided by 2 gives me 1. So I have the absolute value of x minus 5 times 1, or just the absolute value of x minus 5. And that's equal to 10 divided by 2, which is 5. All right, now what's ever inside here can be 5 or negative 5 because I'm not multiplying it or adding anything else. It's just the absolute value on the left side of the equation. So what that means then is that x minus 5 can be equal to 5, but x minus 5 can also be equal to negative 5. Okay? So here then, algebraically, knowing that I can add or subtract anything I want from both sides, I'm going to add 5 here and add 5 here to get rid of this 5 and get x by itself. Minus 5 plus 5 becomes 0. 0 plus x, or x minus 0, however you want to look at that, just returns x. That's that identity we were talking about. And then 5 plus 5 is 10. And we'll do the same thing here, x minus 5. So to get rid of that 5, we add 5. Then over here, we will add 5. X minus 5 plus 5, that goes to 0. 0 plus x is x. And here, minus 5 plus 5 goes to 0. So x is equal to 0. And so that's where we get x is equal to curvy bracket 0, comma 10. All right. Very good. All right, now we're going to do this. The absolute value of x plus 2 plus 3 all over 4 is going to equal 3. All right. So what do I do here? Now remember that this line right here is called a vinculum, meaning that we have parentheses around everything in the top and then parentheses around everything at the bottom. So I have this whole number here divided by this number here is equal to 3. Okay, so I'm going to work this out the first time. We're just going to look at this logically. Whatever this number is right here, I divide it by 4 and get to 3. So I'm going to draw a rectangle around this, and I'm just going to redraw that rectangle there. That is the first thing I do because of the parentheses. Okay, whatever number that ends up being, I'm dividing that by 4, and it gives me 3. Well, now this is a really easy logical thing to think about. What number divided by 4 gives me 3? Well, that's going to be 12. Now, if I didn't know that off the top of my head, what I could do here, since I have an equation, and I have 4 by itself in the denominator, and I'm not adding or subtracting anything to the 4, I can multiply both sides of my equation by 4. This 4 is the same thing as 4 over 1. So it's 4 times the rectangle, 1 times 4. Now you have 4 over 4, and those can cancel. You're just left with the rectangle is equal to 3 times 4, which is 12. All right, and so if you looked at it logically, some number divided by 4 equals 3, you know that the number that has to go in here has to be 12. Okay, so if this number has to be 12, then what that means is if the rectangle has to be 12, that means that the absolute value of x plus 2 plus 3 has to be 12. All right. The absolute value of x plus 2 plus 3 has to be 12. All right. Now what I want to do is try to get these absolute value signs by itself, because then I can look at the plus or minus of what's on the other side of the equation in order to solve for x, because x will have 2 answers since we're dealing with the absolute value. But in order to do that, I need to move this 3 over here. And I'm currently adding it to the absolute value. So to get rid of it, I'm going to subtract 3. And if I subtract 3 on this side of the equation, I must do the same on the other side of the equation. So this becomes 9. And over here, the plus 3 minus 3 cancel. And I'm left with the absolute value of x plus 2. Now, what would x have to be in order to make this a 9? Well, I'd either need a negative 9 in here or a positive 9. So x could be 7 to give me a positive 9. Absolute value gives me 9. Or x could be a negative 11 to where I add 2. It becomes a negative 9. And the absolute value of negative 9 becomes 9. And that's kind of looking at it logically. X can be 7, 8, 9, absolute value 9, or negative 11. Negative 11 plus 2 is negative 9. All right, absolute value of negative 9 is 9. So if we have 9 here plus 3, that gives me 12. So if we go back to our original, let's look at our original here. All right. Negative 11 plus 2, that's a negative 9. Absolute value of negative 9 is 9. 9 plus 3 is 12. And then 12 divided by 4 is 3. So that works. Then my other number, 7. 7 plus 2 is 9. Absolute value is 9. 9 plus 3 is 12. 12 divided by 4 is 3. So we're good there. All right. Now I'm going to look at this algebraically using the rules that we studied last time. So the absolute value of x plus 2 plus 3 divided by 4 is equal to 3. All right, I'm going to multiply both sides by 4. Absolute value of x plus 2 plus 3 is equal to 12. Going to subtract 3 from both sides. Absolute value of x plus 2 is equal to 9. So this can be two things. X plus 2 can equal 9. X plus 2 can equal negative 9. 9 or negative 9 in here, given the absolute value, will both result in 9. Why? Because negative 9 and 9 are both equally 9 units from the origin. All right, I subtract 2 from both sides here to get x by itself. X is equal to 7. Over here, I subtract 2 to get x by itself. X is equal to negative 11. So that's where we're getting that x can be negative 11 or 7. Right. Did want to take a quick minute. I'm noticing that the most missed answers on the quizzes have to do with the classification of numbers. So what I'd like to do is give you guys a number and give me if it's natural, whole, integer, rational, irrational, real, which one it belongs to. And they're going to be more than one. Okay, so remember, every single number you have so far until we get to Algebra 2 is going to be a real number. And every real number is going to be at least irrational or rational. And if it's irrational, then it's irrational and real. It can't be anything else. But if it is rational, it could also be an integer. It could also be a whole number. it could also be a natural number. Okay. So real quick, natural numbers start with 1 and they count up forever. Whole numbers start with 0 and they count up by 1 forever. Integers start at negative infinity and count up the same way forever. Okay. A rational number is if I can make a fraction, not that it shows up to you as a fraction, but if I can take the number that they've given me and I can create a fraction that is equal to that number, then it's a rational number. Okay. So if they gave you the number 9, so let's do this practice. I'm going to give you the number 9. You send to me through chat which group or groups does that belong to? Or which set or sets does that belong to? And go ahead and message me. All right, good job. Somebody messaged with a Q, or I'm sorry, with a G. I think you meant Q. Okay, one of you missed rational. Okay, so here, the number 9 is a natural number. The number 9 is also a whole number. The number 9 is also an integer. The number 9 can also be written as the ratio of two integers, 9 over 1. So if it's rational, it cannot be irrational. And then, of course, it's real. So it would be a natural number, whole, integer, rational, and real. All right. Now, if you know it is a rational number, that means it's also a whole number. That means it's also an integer. That means it's also a rational number, which means it's also real. Okay, because they're all concentric circles. If it's irrational, then it's also real, but it's not any of these. So something like that would be the square root of 7, right? That is irrational because it's the square root of a prime number. But if you had the square root of 64, which was on your homework for today, or maybe yesterday, I forget which one I put that on, the square root of 64 is equal to 8. And 8 is a natural number. Therefore, it's also whole, integer, rational, and real. Okay. I know it seems simple, but that is the number one thing that you guys are getting wrong on your quizzes when you send that in. All right. One more fun problem without absolute value. See if you can figure out what x is. Got one answer, and that is correct. Take your time. We're taking a number, we're adding 5 to it. Whatever that ends up being, we're multiplying it by 2. Whatever that ends up being, we're dividing it by 6. And that will equal 4. All right, someone else just messaged in, and they are correct as well. A third person messaged in, they are correct as well. So if you have messaged in, you got it correct. Very good. Very good. Give another 30 seconds here for anybody else, and then I'm going to work through this. Fourth person, and that is correct. Very good job. All right, so we're going to do this logically. I'm just going to do a purple circle around all this. Okay, so I have purple circle. divided by 6 is equal to 4. What number divided by 6 is going to be equal to 4? That is going to have to be 24. 24 divided by 6 is going to give me 4. So that means that 2 times x plus 5, that has to be 24. Okay. So I can draw another box. Let's make it blue. Around x plus 5, because that's in parentheses. Whatever that number ends up being, I'm multiplying it by 2. So if I take a box and I multiply it by 2, it's going to equal, 24. So what number times 2 gives me 24? What's inside the box has to be 12. So that means that this box, x plus 5, has to be 12. So what number do I increase by 5 to get to 12? Well, that means this number has to be 7. Because if I add 5 to 7, I get 12. 12 times 2 is 24. 24 divided by 6 is 4. So that is logically stepping through it. Now let's do it again, and we'll use the rules of algebra to kind of step through it. So 2 times the quantity x plus 5, all of that divided by 6 is equal to 4. In order to get rid of the 6 in the denominator, I'm going to multiply by 6 on both sides of the equation. That will cancel out this 6 with that 6 and make this 24. 2 times x plus 5 has to be 24. Now I've got 2 times and then parentheses. I can divide both sides by 2. 2 divided by 2 eliminates that. 24 divided by 2 gives me 12. And I'm left with x plus 5. I can drop the parentheses because we're down to just x plus 5. And now, if I'm adding 5, I can subtract 5 from both sides of the equation. Plus 5 minus 5 gives me the x by itself. And I'm left with 12 minus 5, which is 7. And when it's just 7, you don't need to do the set notation. You can if you want. There's nothing wrong with it. It's the way that your homework answer sheet is written up. Sorry, 7. All right, there's also a slightly different way that you could work this out. Now that you know distribution, we have 2 times x plus 5 divided by 6 is equal to 4. I could distribute this 2 through 2 times x would give me 2x. 2 times 5 would give me 10. All that divided by 6 is equal to 4. I can multiply both sides of this equation by 6. That gets rid of that 6 there because it's 6 times this whole thing divided by 6. So this becomes 2x plus 10 is equal to 24. I'll subtract 10 from both sides. Plus 10 minus 10 goes away. You're left with 2x is equal to 14. Then I can divide both sides by 2. The 2's cancel. X is equal to 14 divided by 2, which is 7. All right.